Newton's first law. In 1687, Sir Isaac Newton published his 3 laws of motion. His first law is stated as, an object in constant motion will stay in constant motion unless acted upon by a net unbalanced force, otherwise known as inertia. Inertia is a property of all matter to resist a change in its motion. The inertia of an object corresponds with its mass. An object with very little mass, like a feather, has very little inertia, so it's quite easy to change its motion. Just with a small breeze, the feather drifts away. But a very massive object, like a house, has a lot of inertia, so it's very resistive to a change in its motion. Pushing this stationary house is proving to be very difficult for this man. When the forces acting upon an object adds up to 0, such as this free body diagram, the forces cancel out, and the resulting net force is 0, meaning its velocity is constant. Remember, a stationary object has constant velocity just like a moving object. Its velocity is just 0. At a bowling alley, a bowling ball rolls along the floor with a constant velocity. Its inertia keeps it rolling. Until it hits a wall, the wall exerts a force on the ball, overcoming the ball's inertia and stopping it. As you can see, the forces acting on the ball cancels out with a 0 net force. But the unbalanced force by the wall to the ball changes its motion to a velocity of 0. A catapult also utilizes Newton's first law. When released, an elastic force acts on the arm, and the arm supplies the force to the apple. This unbalanced force speeds up the apple. When the apple leaves the arm, it goes at a constant velocity even without the arm pushing it. But this is only if there is no gravity and air resistance. When introduced, these forces will alter the motion of the apple. A common trick at the dinner table is to pull the tablecloth from under the table, while the objects on the table remain stationary. This effect occurs because of the force of friction trying to drag along the objects is negligible when compared to the inertia of the object, leaving the object stationary. Another scenario involves a wall and a master of karate. Here, he breaks through the wall. This happened because the inertia of his head wanted to keep going right, but the inertia of the wall wanted to remain stationary. With enough velocity, the wall will not be strong enough to stop the head, and the head will continue through the wall. He will continue his constant velocity forever until an external force acts upon him. The final example of Newton's first law is a turning car. The car drives along at a constant velocity along with its heads. When the car turns, its heads still want to keep going forward, and to the passengers inside, they feel like they are being swung to the side, only being kept in place by their seatbelts. To recap, Newton's first law, or the law of inertia, states that an object in motion will remain in motion unless acted upon by a net and balanced force. And it's pretty neat.